Okay, so volume review worksheet page 2, we're also looking at volumes of prisms. So we want to find the volume of the following rectangular prisms correct to one decimal place. So just remember that volume formula is V equals AH, where A equals the area of the base or the cross section and H equals the height going back from that cross section. So for a rectangular prism, we use the formula V equals the area of a rectangular formula, which is LB, and then multiply by that H. So for this first one, our length is 5.8, our base is 5.8, and our height is 5.8. So we'll have volume equals LBH, and so volume will equal 5.8 times 5.8 times 5.8. So volume will equal 5.8 times 5.8 times 5.8, which is 195.112, and the question asks correct to one decimal place. So volume will equal 195.1 centimeters cubed. So then for our next one, our length is 9.6, our base is 5.6, and our height is 3.5. So what we have to do here, write out our formula, V equals LBH. So V equals 9.6 times 5.6 times 3.5. So volume equals 9.6 times 5.6 times 3.5, which equals 188.16. And again, it's to one decimal place. So volume will equal 188.2 centimeters cubed. For our last one, our length is 15.6, our breadth is 3.7, and our height is 3.7. So volume equals LBH. So volume equals 15.6 times 3.7 times 3.7. So volume equals 15.6 times 3.7 times 3.7, 213.564. So to one decimal place, what that is 213.6 centimeters cubed. So now to find the volume of the following triangular prisms correct to 4 significant figures. So the formula we want to use here is again V equals AH, but we'll be using V equals the area of a triangle, which is a half BH, times the height. But instead of using a H for height, I use L for length as my length going back from my triangle. So we have in this first one, our base is 10, our height is 8, and our length going back from our triangle is 30.5. So we'll have volume equals a half times, or our formula, a half BHL. So volume equals a half times 10 times 8 times 30.5. So volume equals a half times 10 times 8 times 30.5, which is 1,220 centimeters cubed. For our next one, we have our base is 5.4, our height is 7.8, and our length going back from our triangle is 10.6. So our formula is V equals a half BHL. So V equals a half times 5.4 times 7.8 times 10.6. So volume will equal, put that into our calculator, a half times 5.4 times 7.8 times 10.6, which is 223.236. Now for the part A, we didn't have to worry about to 4 significant figures because it already was, but for this one, the 4 significant figures is the first 4 non-zero digits, and any numbers after that will be 0, and our last digit could be rounded up. So because that last for our fourth digit is a 2, and then the digit after that is a 3, the 2 does not get rounded up, and it is centimeters cubed. And the zeros after do not matter. So then for our last example in question 2, we have our base to be 12.6, our height to be 7, and our length going back is 28. So V equals a half BHL. So V equals a half times 12.6 times 7 times 28. So V equals a half times 12.6 times 7 times 28, which equals 1,234.8. And again, we need to do this to 4 significant figures. So 4 significant figures is 1, 2, 3, 4. So this 8 will round up this 4 to be a 5. So it'll be 1,235 centimeters cubed. For question 3, we want to find the volume of the following trapezoidal prisms. So again, we use V equals AH, and this is where A is the area formula for our trapezium, which is H onto bracket A plus B. So therefore, our volume formula is H onto bracket A plus B. And then I like to, again, time this by L because we've already used H as a letter. So in this first one, our height of our trapezium is 11.4. Our A value is 20.7. Our B value is 46.8. And our length going back from our trapezium is 15.9. So we have V equals H onto A plus B times L. So we have V equals 11.4 onto bracket 20.7 plus 46.8 times by 15.9. So we put this into our calculator. So 11.4 onto bracket 20.7 times 46.8 times, oh sorry, that's a plus in there, I thought I said the wrong thing, times by 15.9 equals 6,117.525 centimeters cubed. We can round this just to 1 decimal place. The reason I'm going to choose to round this to 1 decimal place is because all of the units in my, or all of the dimensions in my question are to 1 decimal place. But we do need to specify that it's to 1 decimal place because it doesn't ask us to go to 1 decimal place in the question. Okay, for part B, we have our height of our trapezium is 3.6. Our A value is 15. Our B value is 15.1. And then our length going back is this 9 here. So they have added an extra value. So they've added in this 1.6. And that 1.6 is not needed for finding the volume of a trapezium or a trapezoidal prism even. So we use V equals H onto bracket A plus B times our length going back. So V equals 3.6 onto, so we always use our tallest height, in other words, and then our A of 15 plus our B of 15.1, and then we times this by 9. So what we then have is V equals 3.6 onto bracket 15 plus 15.1 times 9 is 487.62 meters cubed. And our last one, we have our height of our trapezium is 6.2. Our A value is 18.6. Our B value is 25.7. And our length going back from our trapezium is 12.5. So we have V equals H onto bracket A plus B times L. So V equals 6.2 onto bracket 18.6 plus 25.7 times 12.5. So V equals 6 onto over 2 bracket 18.6 plus 25.7 times by 12.5, which is 1,716.625 centimeters cubed. For question 4, what we have to do is we have to find the area of this front face here. So the area of our front face, and then what we do is we multiply it by the length or the height going back. So we use our V equals AH, and that is where our area of our front face is that pink and our height is our yellow. So for this front face, we have our area is going to be a combination of a rectangle and a triangle. So our area is equal to 5 times 10, which is the area of this rectangle, plus we then have the area of the triangle, which will be a half times our base value of the triangle is 10, and our height is 3. So once we get area, so we get area to equal 5 times 10 plus a half times 10 times 3, which is 65. We therefore have our volume equals AH. So volume equals 65 times our height is our yellow value of 16.5. So volume equals 65 times 16.5, which is 1072.5 meters cubed. So for this one, you need a little bit of extra space. So for question 14b, again, we want to find the area of this front solid here. So we want to find the area of this solid here, and then we're going to multiply it back by our length going back from that front solid, which we call our height in our volume formula. So our area, it's again a combination of two areas, and what we're going to have to do is split up the areas. So I'm going to split up the area, well, whichever way we do it, we need to know this top value. So we don't know all of the sides to start off with. So we know that this is 14, this is 16. We have no clue what that is. We know that that's 10. We know that that's 6, and we don't know what that is. So what I'm going to do is I'm going to choose to split it this way. However, we need to find out what this value up here is, what this value here is. So we know that this is 16, this is 10. So what this must be is 6, because we go 16 minus 10, and then again we know that this is 14, and we know that this is 6, so this value in here is 16 minus 6, which is 8. So we have our area 1 and our area 2 for our L shape. So area 1 is this little rectangle, or which actually is square, which is 6 by 6. Plus area 2 is this rectangle here, which is 16 by 8. So our area of 6 times 6 plus 16 times 8 is 164. And then our volume equals AH, which equals 164 times 12. So our volume is 164 times 12, which is 1,968 meters cubed. For our last example on this page, again, we want to find out what the area of this front shape is here, and then we want to multiply it back by our length 10. So we need to make sure we know all the sides. So we have some important information that this is 4. We also have that this is 4, and this is 4, and this is 4. And so that means that that is 4 as well. The reason why this is 4 is because we have 4 here and 4 here, and the whole distance along here is 12. So 4 plus 4 is 8. 12 minus 8 is 4. So they are all the same length of 4. So what we're going to do is, simplest way is to cut our shape here, and we'll say that this is area 1 and this is area 2. So our area of area 1 is 4 times 4 plus area 2 is 3 times 12. So how I did that was area 1 is this square, which is dimension 4 by 4. Area 2 is this rectangle, which has dimensions 3 by 12. So 4 times 4 plus 3 times 12, is equal to 52. We then have our volume equals AH, so that's our area of 52 times our length of 10, so volume equals 5